this video is an example for a confidence interval for a population proportion. So in this example, what we're trying to do is to find a 90% confidence interval for the population proportion. They claim that the proportion of males who smoke for a college campus is 12.5%. To verify the claim, a sample of 112 students, assuming that all 112 are males, indicated 16 out of those 112 students smoked. We have to obtain a 90% confidence interval, and using the interval will also verify if the claim could possibly be true. So we'll define the population proportion P as the proportion of males from the college who smoke, and since the problem is asking for a 90% confidence interval, it would indicate that the level of significance alpha is 0.1. In general, the 100 times 1 minus alpha percent CI stands for confidence interval, for P is P hat minus E less than P hat plus E. You could also write it in a fancier way as P in P hat minus E, comma P hat plus E. They are equivalent representations. So P hat is the estimator for P obtained using the sample. E is the margin of error. So using the sample information, we can find P hat as the proportion of males who smoke in the college campus. We find that 16 out of 112 students, all 112 students, are assumed to be male. It doesn't make any sense to look at females when we're trying to observe the proportion of males. So this probability or proportion is 0.1428. The next step to find here is the margin of error. The margin of error is a product of two things. The absolute value of the critical value. Most specifically, it has to be a two-tailed critical value times the standard error. If you're trying to find an interval for the population proportion, so for P, the critical value, the two-tailed critical value, is obtained from a standard normal distribution. Also, the standard error is given by this formula, square root of P hat times 1 minus P hat over n. So if we find the critical value and the standard error, we are halfway down with the problem. So let's find the standard error. The standard error is square root of 0.1428, which is P hat, times 1 minus 0.1428 divided by the sample size, which is 112. Find that answer to be 0.033. So we found the standard error, which is 0.033. The next step is to find the two-tailed critical value. The two-tailed critical value is Z alpha over 2, that is the notation. You can find this using a calculator using inverse norm of alpha over 2 or inverse norm of 1 minus alpha over 2. This will give you the left critical value, which is going to be negative, and that would be the right critical value, and it is positive. It really does not matter in this problem which one you try to find, because we are going to take the absolute value when we try to find the margin of error. So, how do we find the left and the right critical values? Well, all I have to do is make use of a calculator or a table. So, press on, turn the calculator on. Press second, VARS. Option 3 is inverse norm, so press 3. And if you enter alpha over 2, alpha is 0.1, so 0.1 over 2 is 0.05, we will get a negative critical value, which is on the left tail, and it is negative 1.645. In a similar manner, if you want to find 1 on the right, you will find the same number but with a positive sign. So inverse norm of 1 minus alpha over 2 is 1 minus 0.05, close paren, enter, you get 1.6448. So by all means the critical value here is plus or minus 1.645, but when I take the absolute value it would just be positive. Now the margin of error is the absolute value of the critical value that I found times the standard error. So this is 1.645, and the standard error from the previous part is 0.003. I calculated the standard error over here using that formula, and that is 0.003. When I multiply the two, I'd get 0.48, I believe. So let's calculate the margin of error. That is 0.054 actually. So this is 0.054. So that is the margin of error. So now that we have the margin of error and p hat, that interval is easy to find. So the 90% CI for P is P will be between P hat minus E and P hat plus E. We know P hat is 0.1428. 1428 minus 0.054 less than P less than 0.1428 plus 0.054. So using that, I could find that 0.1428 minus 0.054 is 0.0888, while 0.1428 plus 0.054 is 0.1968. So I'd have 0.0888 and 0.1968. So what is the interpretation of this interval? So with 90% confidence, we can conclude that the proportion of students, especially males, the proportion of males who smoke for the campus under consideration is between 0.0888, or that is nothing but 8.88%, and 0.1968, which is 19.68%. Now, is the claim true? They claim that the proportion of males who smoke for this particular college campus is exactly 12.5%. Well, According to the interval that we found, 12.5% falls between 8.88% and 19.68%. Therefore, the claim is likely to be true. So this would just mean that the claim is true. And you should also remember that instead of finding an interval, one can also perform a test for this given problem. And the test that is equivalent to a confidence interval is a two-tailed hypothesis test. And that is how you find the confidence interval for population proportion using the manual approach. But if you wanted to use the calculator, you can obtain the interval with the aid of the calculator, and the calculator is going to do everything for you. So press start, go over to tests, select Z interval, excuse me, not Z interval, start, go over to tests, and you scroll over. Z interval is actually used for mean, and we're looking for a population interval, so you have to use, a proportion interval, so we have to use the one proportion Z interval. So you select A, we have X is 16, we have N is 112, the desired confidence level is 0.9, and all I have to do is press calculate, and that is my interval. And the interval is found to be 0.08847, quite close to what I have here, which is 0.0888, and the upper limit is 0.19724, which is given by the calculator, while I have 0.1968. So either of these answers are correct. The calculator is giving a different answer due to rounding issues, but there is nothing wrong with either answer. I hope that you can follow how to find a confidence interval for proportion using a calculator and a manual approach. Thank you for watching.